So we've just looked at one monosaccharide, which is a triose. We've said trioses have got three carbons. Examples of trioses, we have got L-glyceraldehyde, D-glyceraldehyde, and dihydroxyacetone. We've said dihydroxyacetone is a ketone, while glyceraldehyde is an aldehyde. Aldehydes have got a functional group at the end, while ketones have got a functional group at the middle. Now, the general function of trioses. What is the function of trioses? Of course, all monosaccharides are used as direct sources of energy, but basically, or specifically, trioses are used during glycolysis. So, they are used during glycolysis, and also they are used as a direct source of energy. Now, direct source of energy is basically a function for all monosaccharides, but you need to know that they are also used in glycolysis. Glycolysis is simply the breaking down of glucose in that process when you want to have energy. So you get to break down glucose. So these are used as intermediates, or they are used on the middle for connectivity. It is a long process. So for that process to be complete, you need trioses to be there to make sure that they act as a connector for the process to happen. So basically that is the function for trioses. Now, we need now to look at pentoses. Who does remember pentoses? How many carbons do they have? How many carbons are in pentoses? Musonda.
There are five.
Right. So pentoses have got 5 carbons. Alright. So that means that from the general formula CN H2ON, then their formula is C5 H2O and then 5. Again, this can also be written as C5 H10 or 5. I'll say it again. The formula doesn't tell you how atoms are arranged. But even if this is a general formula for pentoses, there is one pentose which has lost one oxygen. And so the formula doesn't have 5 oxygens but has 4 oxygens because one oxygen has been lost. Please take note. I think it's the only monosaccharide that has less than 5 oxygens. And for biology, they are trick. You don't know how they are going to phrase the question, so know that. Okay, so basically, when you're talking about pentoses, we need to know some examples of pentoses because they are also monosaccharides. It means they're also direct sources of energy. Now, examples of pentoses. The first one is ribose. The next one is ribulose, and then the other one is called deoxyribose. So deoxyribose is the one which has got less oxygen. Just the way deoxy. D means like it's subtraction. Deox means there's less oxygen. So ribose is used in what is called RNA, ribonucleic acid. Deoxyribose is what is used in DNA. These are genetic materials, RNA and DNA. These are the ones which tell why do you look like your parents. Why is it that there are some common trends in a family? So that is because of DNA. So DNA is used for storage of information. All the information that you have in you, why you have got blue eyes, the other one has got brown eyes, that is stored in DNA. why your hair doesn't grow fast, another one it grows fast, why your nails are like that, why you have got such a fingerprint that is stored in DNA. Now, when you are about to give birth to a child, what is going to transfer that information from you to your child is the RNA. So RNA is used for transfer of information. You need to know these functions. This information we're talking about is genetic information, not just any other information. So RNA is used for transfer while DNA is used for storage, and don't swap them. So if DNA was used for transfer of information, any change that happens to DNA, you are going to undergo a mutation, you are going to be sick. That is why people get cancer because of changes in DNA. So that is why it is used for storage instead of transfer. Because in the process of transferring, if any change happens to DNA, you can develop a cancer, and trust me, that is deadly. So ribulose is an acceptor of carbon dioxide during the process of photosynthesis. So that's the function of ribulose. It accepts carbon dioxide. Remember, in the process of photosynthesis, we need carbon dioxide. But in this course, our interest will be discussing ribose and deoxyribose. We are not interested more in ribulose. But know it peradventure. Okay, so having said that, what's the difference between these pentoses? We are talking about ribose and deoxyribose. So ribose and deoxyribose here. Remember the general formula: C5, H10, O5. But I've just said that deoxyribose doesn't have all the five oxygens. So both of these, you need to know that they are aldehydes. So I'm going to show five carbons, but I'm not going to write them, show the carbons. I'll show a skeletal formula. So I've got a double bond with oxygen and then hydrogen there. Okay, look at this. We have got OH here. So this is carbon number one, this is carbon number two. We are going to have another carbon number three, carbon number four, and carbon number five. Here supposed to be five carbons. So all the OHs are on the same side. So if you count in the formula, we've got five oxygens: one, two, three, four, five. So we don't need any oxygen anymore. So the rest will just be hydrogen there, 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 also there. Okay. And then we are going to be here. And then we have got carbon number two, number three, number four, number five. Here we're going to have hydrogen, 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 hydrogen. And then this side I'll put the OH, the OH, 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 and then another hydrogen here. So this one where the hydrogens are on the right, this is called L ribose. So that's not the left, that's the right. Right is called D ribose. And then for this one, you can see the OHs are on the left. That is going to be called L ribose. So this is ribose. Now let's draw deoxyribose. One, two, three, four, five. I'm going to put another one. One, two, three, four, five. So everything, I'm just going to draw the same way you can see here. H here, 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 H here. But at carbon number 2, this is carbon number 1, where the functional group is. So when you're counting the number of carbons, always count from where the functional group is. Carbon number 2, we don't have an oxygen here, we only have an hydrogen. So that's the difference between ribose and deoxyribose. And then for the other one also, sorry, we're supposed to have OHs here. I didn't put the O's. So the rest are the same. It's only at carbon number 2, which is different. And also here we've got H, 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 H. Then you have got OH, OH, OH. But at carbon number 2, we don't have the O. We just have the H there. So this one where the OHs are more on the right is called D deoxyribose. And then the one where the OHs are on the left, that is called L deoxyribose. Okay, so that is how they are. Do you have questions on that? Any question on that? Yes, Jacob.
So like sir, the main difference between the I don't know if you say ribose and
Mm-hmm.
the oxyribose. See, the main difference is structure or in the way hydrogen they are positioned.
Okay, wow. So basically the structure and the placement of the hydrogens are the same. The only thing that differs is the second carbon. Carbon number 2. We can see for ribose it had OH in D ribose, but for deoxyribose it doesn't have an O, it just has an H. And then when it comes to also L ribose, there's an OH here, but here there's only an H. So deoxyribose has lost one H at carbon number 2. So that's the difference. Carbon number 2 and deoxyribose doesn't have an oxygen. Is that okay?
Yes, sir. So, but the number of carbons is the same.
The number of carbons are the same and the number of hydrogens are the same. What is only different is the number of oxygens, because in deoxyribose one oxygen has been lost. That's cool.
Yes, sir.
Okay. Now, because ribose and deoxyribose, the number of carbons are just too many. These are not found as straight lines. They are not found as straight structures. They are going to be found in a ring. So let's see how rings are formed. Now you need to know that the ring is only formed in the D isomer. Please have this in your mind. The ring is only formed by the D isomer, just like the D isomer is a common one. So when we start with ribose here, we want to form a ring. I'm going to draw first ribose. And this should be the D isomer, not L. So I've got carbon number 2 there, carbon number 3, number 4, and number 5. If this is supposed to be D ribose, which side do we expect to have the OHs? Is it on the left or on the right? Which side?
Right.
Good. On the right. So we're supposed to have OH there, and then OH also there, OH also there, OH also there. And then we've got H, we've got H, we've got H, we've got H, we've got H. Okay, so now what happens for the chain to be formed is the second from last carbon. Now, This one has got 5 carbons. If I say the second from last carbon, that will be carbon number what? Anyone to say? It has got 5 carbons. So if I say second from last carbon, that will be carbon number what?
Carbon number 4.
Okay, good. I want you to speak so that at least it will stick in your mind, because trust me, people get confused when such a question comes. So the carbon number 4, which is here, is going to go and interact with the carbon containing the functional group. Now remember, ribose is an aldehyde. Aldehydes have got a functional group at carbon number 1. So always the functional group is going to be on carbon number 1. So the carbon containing the functional group is called the anomeric carbon. And know this in your head. Carbon containing functional group is called anomeric carbon. We also have what is called a chiral carbon. The other name for chiral carbon is asymmetric. Asymmetric means it is not symmetrical, like the way a person is. If you cut a person on half, the left is going to be the same as right. So an asymmetric carbon or a chiral carbon has got 4 different bonds. Please, 4 bonds which are different. They shouldn't be the same. These are also exam questions. For example, when you have got a carbon which has got groups OH, and then it has got maybe another group there, it has another group like this. So you can see all these things are different. So this carbon is called a chiral carbon or asymmetric carbon. If you look at this carbon here, it only has 3 bonds. So it is not chiral carbon because it only has 3 bonds. A chiral carbon should have 4 bonds and they should be different. So if you've got a carbon like this, H, and then maybe you've got R here, and then CH3. This is not a chiral carbon. Why? Because these two are the same. All of those things around should be different. And this is an exam question. They ask how many chiral carbons are in this molecule or in this substance. So just have to count how many carbons are bonded to 4 different things. For example, this carbon here has got H, it has got H, it has got OH, and then it has got also this group which is this side. So it is not a chiral carbon because it has got 2 H's. So you can count in the ribose how many carbons are chiral. Okay, I just needed to state that because it's a common question which comes in the exam. So we are saying the carbon at position number 4, that is second from last, interacts with carbon at position number 1. So that interaction happens in such a way that you are going to form a ring. So what is going to happen is the oxygen of carbon 4. Which one is carbon 4? This one here. The oxygen at carbon 4, which is first, you've got also the oxygen of the double bond. Please pay attention to this because I've seen these questions in the exam and they are quite tricky. So the oxygen of the carbon to oxygen double bond, which is this oxygen here, is going to bond with the hydrogen of carbon number 4, this hydrogen which is here. So that is what is happening. Please know this. This is an exam question. The oxygen with a double bond at carbon number 1 is going to bond with the hydrogen at carbon number 4, forming an OH group. This is called hydroxy group. Now, this hydroxy group can either be above or below. Now, let's draw how it's going to appear. So what you are going to say, since this one has got 5 carbons, you are going to see something which looks like a pentagon. So I'm going to draw two. Okay, like that. So When this thing is turning, remember it's always D which turns. It is going to turn in this way. Please, you need to know because at times you might forget the structure, but if you know how to get it, you are going to remember. So it's going to turn in this way, meaning that like the shape for this thing is going to bend like this. Okay, that's how it's bending. So this carbon which is here is going to be carbon number one. So which one is carbon number one? Carbon number one is here. Let me even label them: one, two, three, four, five. So this is carbon number one, the anomeric carbon, or the carbon containing the functional group. So if you see when this bends, and how do you count the carbons here? This will be carbon 1, this will be carbon 2, this carbon 3, carbon 4. What will be carbon 5? You are going to see that. So carbon 2 is here. So if this thing turns like this, the OH you are seeing is going to be down, whilst the H is going to be on top. And then also here, because this thing is turning like this is carbon number 3, and this is carbon number 3. And the OH will still be down, and then the H will be inside, and then this is carbon 4. So also here it will be like that. Okay, the now for this portion which is here, let's pay first some attention to that. This is carbon 1, carbon 2, carbon 3, carbon 4, and carbon 5. We have just filled one. This is carbon 2, of course, this is carbon 3. So we are on carbon number 4. We want to see what happens at carbon number 4. So at carbon number 4, what we are going to see is, since we had, remember, we have got a second from last carbon that has got what? That has rotated. This carbon number 4 here has interacted with this. That, what has that formed? It has formed an OH group. Now let's put first that OH group before I talk about the carbon number 4 and 5. This hydrogen interacting with this oxygen forms OH. This OH can either be on top or down. The rest are going to be the same. It is just the OH which can either be on top or down. Now when that happens, we have got an hydrogen that has remained on carbon number what? And by the way I'd drawn this doesn't show what I'm talking about. This is not carbon number, this is not the second from last carbon. So this thing, this red line was supposed to move from here, go like this. Please forget about here, that is the last carbon. Okay, okay, for smartness sake, so that I don't confuse anyone, let me just draw that again, just again. Okay, so we are saying this hydrogen, which is from the second from last, interacts with this oxygen which is here. Now we can put that. This is an oxygen, and you know where it has come from. So this oxygen you can see on top here is the oxygen that has remained here. Remember, the hydrogen has interacted with the oxygen on top, so that oxygen that remains is the one which you can see on top there. And then one thing that is going to happen is, at this point we can have the OH on top or the OH down. Which OH? The OH formed by the hydrogen, which you can see here with the oxygen that is on top. So on that one I've put it on top, and then here I'll put it down. The rest, I hope you saw how I was putting them. The OH, the OH, H, H. Okay, Now, the thing here is this. Count the number of carbons. Carbon number 1 is the one which is here, which has given us the OH on top. Then carbon number 2 here is the one which has given us this OH down. Carbon number 3 also is the one which has given us the OH down. Carbon number 4 is this one which you can see here. Now at carbon number 4, something interesting is going to happen. Remember at carbon number 4, this is where we removed this H, and the O is the one which you can see on top there. So what has remained at carbon number 4? What is remained is an hydrogen just. So that hydrogen is, you are going to see it down there. I'll also put it here down. And then after that, the only group that has remained is this group which is down here. Remember there is a carbon here. Okay, so that carbon is C, and then you have got an O here, and then we have got these two hydrogens here, which you can see. So I've got an hydrogen and another hydrogen. There are two hydrogens there. So, and we also have another hydrogen here, because we've got three hydrogens that have remained. That other hydrogen, we are going to put it in front like that. So this group that remains, we are going to see it on top here, also here. So these are the structures now for the ring form of ribose. So if it seems tricky to remember, just know how we've gotten it. Okay, just know how we've gotten. Now we haven't talked about this hydrogen which we meant here. That hydrogen can either be on top there or below here. So the name is going to change. Remember, this is D ribose. They all came from D ribose. So now to name the name, this now takes us to what we named as, what we're talking about as stereoisomers, which have got different arrangement of atoms in space. So when the OH is down, this is called alpha. So this is going to be alpha ribose. When the OH is on top, it's called beta. So this is going to be beta ribose. So that is alpha D ribose, and that is beta D ribose. Now when you see a structure that looks like a, a pentagon, this is always called a Furanose ring. When you see a structure which looks like an hexagon, you are going to talk about this. This is called a Pyranose ring. So because this looks like a pentagon, that's a Furanose ring. So therefore the name can also be said as, this is alpha D ribo. Instead of me finishing ribose, I'll say ribo Furanose. And then this is beta D ribo Furanose. So those are the names, and that's where we're going to end for now.